Hello, this lesson we're going to discuss three-phase auto transformer. So we're going to talk about auto transformer first. The auto transformer have some advantages. They are more efficiency because they use less coil, less core, and they cost less to build them, and it's simple. They have better voltage regulation because they have a lower internal impedance. But also, auto transformer have some disadvantages. One disadvantage is the auto transformer, because the low internal impedance, so they will have a higher fall current. If we have a short circuit or anything happen, the fall current will be higher for auto transformer. Also, the auto transformer, if something damage the inside auto transformer, they could have a very high fall voltage happening. So here's two examples. If I use an auto transformer from a high voltage 2.4 kV to 120 volts. So 120 volt will be on a very small section of the transformer winding. But if that portion of the winding ever develop or open, all the 2.4 kV gonna cross this 120 volt on the secondary side. They will cause your load get a very high voltage. Even we use the auto transformer between not such a high difference between voltage. So I use an auto transformer to reduce the voltage from 240 volt to 208 volts. If for this 208 volts, they will occupy a large portion of the winding, but if that winding ever have a break, the current goes through the smaller portion of winding, gonna causing the core to oversaturate. That's gonna induce a very high voltage on this break down here. So that's why even auto transformer have lots of advantages. We only use them for certain applications because of the danger related to the auto transformer. In three-phase auto transformer, we're going to mainly cover three main auto transformer. One is three-phase Y auto transformer. It's usually used for starting the large three-phase motor. And we have a three-phase open delta auto transformer. It's usually used for starting a kind of smaller size three-phase motor. Compared to three-phase Y auto transformer, it uses one less transformer, so cost less to use. The third one is called the three-phase zigzag auto transformer. The main purpose for three-phase zigzag auto transformer is to reduce the harmonic effect in the power system. So we're going to talk about power quality and in the power system. First thing, the power quality is not the power fact. The power fact is caused by the inductive load. We have a motor, they are inductive load, they will draw lagging current. But the power quality is called the distortion of the original perfect sine wave. We all know what a sine wave look like. If we have a harmonic in the power system, they're going to distort the sine wave. I will show you a few pictures later to see how the distorted sine wave look like. But the power quality is regarding that sine wave. We want a perfect sine wave, so we don't want any distortion in there. But because nowadays we use lots of non-linear load in our power system, the non-linear load gonna cause in the harmonic current of voltage into the power system. The non-linear load is defined as a diode, transistor, SCRs, IGBTs, switching power supply, like VFDs, anything use those electronic components. They're going to chop off the waveform to either do rectification or to do phasing control. They are considered as nonlinear load. they will induce the harmonic into the power system. The third harmonic is the most worst for the power supply system, because if we learned the three-phase, we have three-phase 4-wire Y-connect system. We know if we have a balanced load on each phase, the neutral is supposed to carry zero current, because all the three phase current, when they combine, if they are equal, they are 120 degrees apart, they're going to cancel each other out, so the neutral is going to carry zero current. But for those each phase, if they have a third harmonic in there, it's not going to, when they come to the neutral point, they're not going to cancel each other out. They're going to trip, because three of the third harmonic, they not cancel each other out. They are in phase with each other, so they're going to be 3 times more higher in the neutral conductor. When they tripled in the neutral conductor, they're going to cause the neutral conductor to overheat. And for those, because the harmonic in the electrical system, they distort the sine wave, so the distorted sine wave going to cause the problem for our electrical or electronic device or equipment. For example, the motor, three-phase motor, they're not going to run so smooth because the distorted sine wave, the torque developed by the motor, not going to be perfect anymore. We use the zigzag auto transformer. We try to reduce or eliminate the third harmonic or the harmonic current or voltage in our power system. The connection for the zigzag transformer is they cross-connect different phases transformer together. They creating a path for the neutral current for the third harmonic to circulating in there, and they try to providing a path for they to go to the ground, not go to the power system. There's other type of harmonic filter. We have an active filter. The active filter is we using transistor, we using capacitor, we use electronic device. We creating opposite current to cancel or eliminate those harmonic current. We have a passive harmonic filter. Passive harmonic filter is creating a path for the harmonic current to bypass or to shunt those harmonic current so they don't go into our electrical system. I will show you a few pictures later, and after that, if you have any question, you can always chat with us online or send us emails. So here's a picture of three-phase zigzag transformer. It's used to filter out the third harmonic in the transformer. This is a picture of a fundamental waveform with third, fifth, and the seventh harmonic in there. So it changes a perfect sine wave into almost look like a square wave. Here is a picture of a perfect sine wave with third harmonic add on to top of the fundamental waveform. So instead of a perfect sine wave, you can see the peak of the sine wave dipped, so it have two peaks beside the original peak on there. Here is a picture of a fundamental waveform and a second harmonic at the same amplitude adding together. So for this waveform, the solid line you can see it's not anymore any sine wave. It changed to a different type of waveform. So here the field picture I try to show you.